In today's lesson, we are going to be looking at optimization given a fixed parameter. So optimization is basically we want to get the most or the best amount or of the best of a situation, right? If we're trying to optimize something, we're trying to get the most out of it, the best out of it, right? You can think of optimizing the components or optimizing the specs on a computer. You're trying to get the most out of your computer, the best that you could given a fixed variable. So in our case, we're looking at trying to get the best given a fixed perimeter. So a farmer has 2 bulls and 20 cows he needs to build a pasture for. He would like to build an enclosure using the existing 800 meters of fencing he has available. So that's the restriction right there. He has 800 meters of fencing. He needs to figure out what design can he come up with that gives him the most area. So we're trying to optimize the area. So we're going to look at 3 different shapes. So we're going to look at a circle. All right, so if we have a circle, kind of roughly draw it here, we need to make sure that this distance around is 800 meters. Right, that's the amount of fencing we can use, so that is, we want to use all of it. Right, if we're trying to get the most area, we're not going to not use any fencing. We're going to use all that we can. So in order for the entire distance around to equal 800, that would tell us that the circumference has to equal 800. Well, why are we talking about circumference when we're trying to look for area? Well, if I want to figure out what area this gives me, area equals pi r squared. However, we don't know what r is. We can figure it out though using the circumference formula because we know what the circumference is. So in that case, we can take the circumference formula, c equals pi times diameter. C we know is 800, so 800 equals pi times diameter. And I can get d by itself by moving pi over or by dividing by pi. So 800 divided by pi is equal to the diameter. Let me just kind of organize this a little bit more. So then that means that my diameter would equal 254.65. So that is my diameter. I can then figure out the radius from that because we've mentioned before that the radius is half the diameter. So 254.65 divided by 2 gives us 127.38 roughly. 127.38. Now I can use that to find my area. So area equals pi times radius squared, so pi times 127.38 squared, which gives us a total area of 5,948.58 meters squared. So that is the total area that we would have given this, or given using a circle. Let's look at a square. If I wanted a square, it means all sides are equal. If I have 800 meters of fencing, then I know that each side would have to be a quarter of that, or 800 divided by 4, which is 200. So each side of my square would be 200. Area is length times width, so in this case 200 times 200 equals 40,000 meters squared. If we had a rectangle, now of course there's a lot of rectangles that we could use. Let's make it a little bit specific and say 100 meter short sides. So that means if I were to look at my rectangle, these short sides are 100 meters. That means that the top ends, or the top sides and the bottom, the long sides, need to be 300. So again, area equals length times width, because again, we want to figure out what area we would get. 100 times 300 equals 30,000. So which shape gives the biggest possible area? Well, if we look at all three of them, area here, when we look at all three of them, we find that the circle gives us the largest possible area. So you might think, well, if the circle gives us the largest area, why are farmers not using circles? And there are other factors that come into play, because if you think of how land is divided up, or how maybe we place certain things together, it might not be as easy to group circles together. If we try to group circles together, there's lots of wasted space in between, right? Because they don't fit quite nicely with other things or with other circles. You could think of how the land is divided up. Usually it's divided up into squares for along the same reasons, because otherwise you'd have empty space or misused space. So even though a circle may give us the largest possible area, depending on the situation, it may not be the most convenient to use. If you were to build a right-angled triangular shaped area, what would be true about the base and the height? So if we were to draw, or if you were to decide to come up with a triangle, we have the height of our shape, we have the base of the shape. What would be true about the base and the height? If we wanted to think about what we've already kind of looked at. So if he was going to build a right angled triangular shaped area, we would find that the base and the height are the same. One reason is because, again, looking at our previous answers, aside from the circle, the square is the best option, which means all sides are the same. So if I wanted to create a rectangular shaped area, I would need to make sure that the sides, the height and the base, are equal in measurement. So he decides instead to use an existing fence as one of the sides of a rectangular shaped enclosure. So he already has an enclosure there. He wants to then just kind of add on to that and use his 800 meters to build 3 sides. What optimal measurements would work for the new enclosure? Well, we have our dimensions here. This side is already kind of used. Oops. This side is already used, so we don't need to worry about this side. We just need to focus on the other remaining sides. Now, if we were to think of it, if he is to make the width 50, what would the length be? Well, the length in this case, 50 and 50 is 100. He has 800 meters total, so the length would have to be 700. If we kind of go through this same process, 100 and 100, this would be 600. 150 and 150, this would be 500. 400, 250 and 250, would be 300 left over. 200 left over. And 100 left over. Now we need to figure out, based on this, what areas would we have? Well, 50 times 700, 35,000. 100 times 600, 60,000. 150 times 500, 75,000. 200 times 400, 80,000. 250 times 300, 75,000. 600 or 60,000, 35,000. So by looking at this table, we can figure out which dimensions would give us the ideal or the largest area. If we weren't too sure, we could graph that as well. And we would find that as we went along, 50, 100, 200, 50, 100, 150, 200, 250, 300, 350, we would find that the largest height is in the middle. So again, graphing it, we see that it would come up and then it comes back down. So you might remember this type of shape from previous years, but this would be a parabola. I guess actually it would go over 350 and 400. So we would actually, so again, we can see the middle here. Now what's unique about these measurements? Well, the width equals the width, right? The ideal measurements we just mentioned, 200 by 200. What's the ideal measurement though for the length? We found that it was 400. So the length is actually equal to double the width. So this is something unique about when we have one side enclosed. We go back to the original. If we're using all sides aside from a circle, when all sides are equal, we have the largest area. However, if we're only down to 3 sides, the optimal dimensions are the length being twice as long as the width. So let's look at some examples. A farmer wishes to fence in a pen that holds pigs. The farmer has 80 feet of fencing available and will build the pen along one side of the barn as shown. What dimensions would give the greatest area for the pen? And we want to use algebra to solve. So using what we just found, that when we're enclosing something with 3 sides, the width will equal the width and the length will equal twice the width. So if I look at this figure, if I'm going to roughly label with variables, width and width, this is 2w. So that means I have 80 feet and I need it to be broken up amongst these 3 dimensions. When we're talking about fencing, we're actually also talking about perimeter. So that means that the width plus the the length has to equal 80. Well, w plus 2w is actually the same thing as 4w. So 4w equals 80. We talked a little bit about solving equations. Divide both sides by 4. W equals 20 feet. So that means when I actually go through and look at my dimensions, I have 20 feet, 20 feet. The long side is double the short side. So this is actually 40. And that would give me the largest area. A horse trainer would like to build an area for her horses. She would like to enclose a rectangular shaped pasture that will give her horses the biggest possible area to graze. She has picked a spot on her land that borders on her racetrack with an existing fence and needs to create 2 separate areas. If she has 600 meters of fencing available, what dimensions should she use? Well, we're going to kind of go through this and look at this a different way. We're still going to use the same idea. Right? We have a length, we have a width, and a width. Right? Because this is something different with enclosure in the middle, with creating that separate enclosure, we have to look at this slightly differently. So let's kind of use some algebra here. We know our dimensions are, or what they work out to. So we know for perimeter, we have the length plus 3 widths has to equal to 600. So if I wanted to rearrange this, I could find the length, and that would equal 600 minus 3w. Right, so all I'm doing is rearranging. I can use this to help me find my area. So what I'm going to do now, I know the area is length times width. So in this case, I know my length. I can actually substitute something in to find out that width. So 600 minus 3w times the width. I can use distributive property to multiply this through. So 600w minus 3w squared. And I can actually factor this now. So I can factor this. We'll look at 3w times 200 minus w. So this will go into a little bit of our factoring as well as our quadratics. So now that our quadratic formula or our shape is in the factored form, I can find what my middle piece is. So if we kind of go back to that quadratic or that parabola that we showed on the previous one, the optimal value was right in the middle between two end pieces. So these two end pieces, if we remember, are called intercepts, x-intercepts. And in this case, that would be when the width or the area works out to 0. So the only way the area works out to 0 is if one of these two factors works out to 0. Well, the only way the first one can work out is if w equals 0. For the second one, the only way that can work is if w equals 200. So that means that our two end pieces are 200. So this middle ground would be 100. So we would get the optimal area when the width is 100 meters. So in this case, the optimal width would be 100. And we can find the length. So the length is equal to 600 minus 3 times the width, which is 100. Or we get the length is equal to 300 meters. We can see a relationship kind of here as well. Depending on how many sides I have of my divided figure, if I'm only using one of those sides, and what I mean by that, here I have a long side and 3 short sides. The long side is 3 times the width of all the short sides. So we can, using that understanding, if I had 4 sides, I would hypothesize that the length is going to be 4 times the length of a short side. So we can use that to kind of help us figure out, or maybe even help us to guess what the dimensions are going to be. If we look at the previous example, we have 1 long side and 2 short sides. The long side is twice the length of a short side. Right? So again, you can imagine what would happen if, say, just kind of off to the side, say we had a long side and we divided it up into, mentioned 4 sections, maybe divide it up into 5 sections. I would hypothesize that the length, if we call these widths, the length would equal to 5 times that dimension, assuming that the other long side is already used, which does make sense because each thing should probably create a square, right? And talking about a square having the ideal dimensions, so if this is a width, 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 this would ideally make up our long side. So again, just kind of something to think about, but we can kind of start to see a relationship when we have a fixed area and one side is used up. Again, don't forget at the very beginning when we talked about having fixed dimensions, which one gives us the best or the largest area, but which one also might be the most practical. Circle gives us the largest, square is probably the most practical while still giving us a large area.